Your Holiness, one of the themes that you have requested that we consider at our time together is the theme of neuroscience and also a related theme of consciousness. These themes have been a part of the Mind and Life dialogues from the very beginning. And with all due respect to my wonderful colleagues in physics, I think that the practical consequences of the dialogue with neuroscience have been very evident in the stimulation of actual research, which has been very exciting and I think extremely important for so many different areas. And I'd like to begin by just asking the question, why has neuroscience been such a vibrant opportunity for the dialogue between science and Buddhism? And I think that at its very root, many of the questions that have been historically among the most important in certain branches of neuroscience are really questions that also, I think, are central to Buddhism. Questions such as, is there a self? Where might it be located? Questions like, is all thought conceptual? What is the difference between, or the relation between perception and cognition? What is the difference between afflictive? So regarding the issue of perception and cognition, one of the questions that neuroscientists have been particularly concerned with is the extent to which the brain provides a faithful and veridical representation of the external world. Or is it more the case that the brain constructs reality in some way? This is a question that we'll be hearing more about over the course of this week, and some of the implications of neuroscientific research related to that question will become apparent. Also, a question that you frequently ask, Your Holiness, what is the difference between non-conceptual and conceptual mental activity? And is there a difference in the brain where we can distinguish between them? It's a question that scientists, neuroscientists, are beginning to ask as well. Also the question of whether there is a difference and what the difference might be between afflictive and non-afflictive emotions has been very central. But I think perhaps the most important issue is that I think that we could say that the third noble truth in Buddhism really, I think from a neuroscientific perspective, is fundamentally concerning the possibility of neuroplasticity, that is, the possibility of change. And the fact of neuroplasticity, the fact that the brain can change in response to experience and in response to training, provides us with, at least in scientific terms, some idea about how the path of liberation might actually occur, how we might find a way out of suffering. Because if the brain can change in these ways, perhaps this provides some important insights about how suffering may actually be reduced. And so I think this is an area where there has been a terrifically important connection between the study of the brain and Buddhism. So I would like to introduce this topic with just a few facts about the brain and then some illustrations to show that when we go about our world and information comes through the senses, much of that information may be processed by the brain, but is not necessarily conscious. but yet it still affects the brain in important ways and can change the autonomic nervous system in ways which may influence our health. And this gives us some insight about what the role of conscious awareness might be in our minds and brains, which will be a topic that we'll consider in detail in the next few days. So, one of the things that we're learning about the human brain is that it's probably the most complicated piece of matter that exists in the universe, or at least on this planet. There are more than 20,000 genes which are expressed in the brain that play a role in the activities of the brain. There are more than 100,000 distinct types of cells and constituents that we find in the brain. These are distinct physical entities that play a role in the operation of the brain. That's approximately the number of brain cells in the human brain, and this is approximately the number of connections among those brain cells. So it is a vastly complicated piece of matter, and the honest truth is that scientists have very little idea about how this actually works at this point in time. Our knowledge is really in a very early stage. There are really an astronomical number of ensembles of these are collections of cells that accomplish specific types of tasks. We don't know how many mental states there are. It could be a virtually unlimited number of mental states. Not in terms of category, episodes, yes. A millimeter cubed is approximately the size of the top of a pin. And there are approximately 20 to 30,000 neurons or brain cells in that little space of the head of a pin. There are, in that same amount of space, there are approximately 4 kilometers of axons, which are the connections between brain cells, in just the size of the tip of a pin, approximately 4 kilometers. And then there are a very large number of synapses, which are the physical connections that exist among cells in the brain. So all of this is just to emphasize that this is really, really complicated. And there are a huge number of interacting parts. And one of the challenges for scientists is to better understand how this all works together. And that is still very much an open question which we're at very early stages with. One of the areas of the brain, each of our neuroscientists has a favorite area of the brain that he or she studies. This is one of the areas that I study a lot. It's that little purple spot, and it's called the amygdala. And you've heard, Your Holiness, about the amygdala at many other occasions, and it seems to play an important role in afflictive emotions, particularly, although it plays a role in all emotions. Now, we're beginning to learn a little bit about the connections that that area of the brain makes with other areas of the brain. And in this next slide, this depicts all of the known connections. Every one of these lines is a verified connection that exists between the amygdala, which is right in the middle. That's this area right here. And every line is a known connection between this structure and each of these numerical and letter positions represent a different part of the brain. So this is illustrating just the connections of this tiny little structure with other parts of the brain. And again, it underscores how extraordinarily interconnected this is. And again, we're still at very, very early stages of this work. Now, one of the things that neuroscientists are learning is that in a very real sense, the brain constructs our experience of reality. It does not faithfully represent the outside or the inside world, but it transforms information and represents it in this transformed way. And so what we experience in our seeing or in our hearing is not a faithful representation of what exists outside. And so, for example, we know that certain animals can hear things that humans cannot hear. We know that they can see in certain ranges of light that humans cannot see, and yet those influences are still present in humans, and some of them can still influence the brain, albeit in ways that we're not necessarily conscious of. So one of the kinds of experiments that neuroscientists do, and this is a demonstration that I showed in Delhi, and this is what we call the attentional blink, which is an experience that people have very often where something might occur in the environment and they're simply not aware of it, and it's as if their mind was not paying attention. Their mind was fixated on one thing and they were unable, therefore, to see another thing. This is an occurrence which happens a lot, and the reason why neuroscientists have become so interested in this, particularly those who are interested in the dialogue with Buddhism, is because one of the hypotheses or one of the invitations from the Buddhist tradition that we've learned is that some of these qualities that neuroscientists have studied may not necessarily be obligatory properties of the nervous system. They may be potentially trainable. That is, we may be able to actually enhance our attention in ways which allow us to see things that many people may not necessarily see. So in the attentional blink, and we can actually do this little experiment, if everyone just looks at this cross, and I will be showing a series of letters and numbers, and just pay attention to the numbers, and I'll ask which numbers that you saw. Was the number 1 presented? How many people saw the number 1? Number 2, number 3, number 4, 5, 6, 7, 8, 9. Okay. So what was actually shown is, but it is a little more difficult for most people to see the 7. So the way this worked is I presented a series of letters, then the number 3 occurred, and then there were 1 or 2 letters, and then again the number 7. People get so excited about seeing the 3 that they fail to see the 7 very often. So it turns out that 3 months of Vipassana meditation practice improves a person's ability to see the second number, to see the number 7. So we know this has been an important observation because it teaches us that in contrast to what neuroscientists first thought, which is that this is an obligatory property of the nervous system, that the nervous system goes into some refractory mode, meaning that it's taking a rest. After seeing that first number, it kind of shuts down to restore itself. Then it can see the next number. what this observation suggests is that these are, at least to some extent, malleable. They're plastic. They can undergo change through training. Now, another example, scientists call change blindness. What I'm going to show here is a series of pictures. And there will be a slight change from one picture to the other. And see if you can, just by looking at these pictures very attentively, notice where the change is. So I'll show them a few times. Did anyone notice a change? I'll show it once more. Now I'll show it in slower motion so that you can actually see better what changed. Now if you notice in the corner here, there was a little sign that initially in the first image was on and then it turned off. So I'll show another example. I'll show it again, and then I'll slow it down. And if you notice there was a light at the top, I'll do it once more. The light was present and then it went off. Now, I'll show it once more so everyone can see it. The light at the top and then goes off. Most people or often fail to see this change. And again, studies have shown that meditation practice, certain kinds of meditation practice, can actually influence this capacity. So another area where we see this is in detecting very subtle facial expressions. And you know your friend Paul Ekman has been one of the leading scientists in this area. And what I'd like to show now is just a couple of faces and just very quickly see what your impression is in terms of which face looks more happy or more friendly. The first or the second. So here's one, and I'll show it to you. Another one, and tell me which looks happier, the first or the second. How many people thought the first looks happy? How many people thought the second looked happier? Okay, I'll show you what I actually displayed. So what was displayed is, and then that. So it was first a fear face, then a neutral face. And in the second case, what I displayed was this. A smiling face and then a neutral face. And so it turns out that these facial expressions can influence your judgment of a neutral face, even though you may not be aware. And one of the questions that we're investigating with the intersection of Buddhism and neuroscience is whether individuals who've trained their mind are better able to see these very fine details in these kinds of images where untrained minds may be less able to detect these very subtle differences. We test that first. We test the eyesight. Very important, yes. So I'd like to just end with a few additional words about the brain as a source of both delusion and insight. The idea that the brain constructs reality suggests that it never faithfully represents the external or internal worlds. And delusion, which is something that we I think can really profit from the intersection of neuroscience and Buddhism, delusion. Distorted perception, but also potentially afflictive. So delusion can result from distortions created by emotions, which can influence our perception, our beliefs, and our expectations.
The way in which you're using the word constructivist, are you already suggesting that you are at the level of thought, or is it still construction could be taking place at the pre-conscious level.
Absolutely pre-conscious, yes.
울롱도
Not necessarily at the level of thought.
러시아 도백감을 멤버죠. 울롱도 가서 그런 로게 원고도.
Yes.
She's wondering, you know, the word construction. கொஞ்சம் நம்ப நம்ம கே시게요 말이야. You know, His Holiness is relating, you know, this whole notion of construction versus faithful representation. He's trying to correlate that with the Buddhist debate about whether when mental perceptions or mental processes represent reality, is it just a one-to-one mirroring without any mediation, or whether you know, the mental processes imposes a form as a medium to kind of organize the material and perceive it. So there is that discussion. But the construction here. Okay, so then there is also just it has implications for whether what we perceive is actually kind of faithful to what is there, or whether it's a form of a distortion. Anyway.
Size illusion would be a good example.
Yes, Arthur was going to show some slides illustrating the idea that sometimes things may look a different size, but they're actually the same size, but because of the context in which they're embedded, they can look smaller or larger.
Richie, can you just get that image there? Would be
Sure. This is from Arthur. This is from Arthur. Arthur, do you want to describe it? I'll be your projection man.
So, Your Holiness, you'll see here two monsters, and they're in a hallway. Which is bigger? What do you? Is the first one bigger, or the second one in the back bigger? Good. Okay, let's show the next slide.
Oops.
There's an arrow. Whoop! Don't go too fast. There's an arrow which is the same size. Here. Go slowly. All right. So I've moved the arrow. They are the same size. Most people would judge the back one to look bigger than the front one. Go to the next. Here you have three soldiers. Which soldier is taller? Most people would judge the soldier on the left to be taller than the soldier on the right. But again, that's right. Richie, could you go to the next?
because of the line.
Okay, now another move, that's it. And then one more. These are actually all the same size, but as you say, Your Holiness, because of the lines that are on the, I don't know whose microphone's rustling, but because of the lines in the background, you judge the size relative to the context. All right, so what you're seeing and judging as a cognition is not a veridical or accurate representation of the physical size, but it's a subjective impression.
So because in Buddhism, Buddhist epistemological text, there's a lot of discussion of various forms of perceptual illusions and where the source of illusion lies. So this one would be categorized as the source of illusion lying in the actual context or the object, in the field.
So the object.
Field.
Go a little further. Can you skip to the Fraser spiral, just to give a kind of fun? We'll conclude this with a final demonstration. It's called the Fraser spiral. Here, Your Holiness, one sees, most people will see a spiral where it's a kind of circle that goes in towards the center, right, where it gets smaller and smaller. I'm going to put a spot, a star, if you hit just once, on the top. You can see the star at the top. And now we're going to move at the top of the spiral. There's a star, a red star. Yeah? Okay, now we're going to move it around the spiral and follow it. Notice it goes to the same place. You can go back if you want and then forward again. Just backwards. And that's it. There it goes again. So if you trace your finger around the spiral, it's not a spiral, it's actually a circle.
Same distance, right?
Same distance, yeah. It's
스파이럴 작용을 해. 그걸 안 돼. 아주 원식 제비는 스파이럴.
you see a spiral, but if you draw your finger, you move your finger, it's only a circle.
So
In reality, on the right-hand side in the lower, you'll see that there's a series of concentric circles in the lower right.
So it's basically a concentric circle.
It's a set
with
of concentric circles.
No difference in
no
the
difference,
distance.
yeah. So this is, is some evidence concerning the relation between perception and cognition. What is it one sees? What is it one cognizes and knows? It raises many interesting philosophical issues.
Your Holiness, I wanted to just review another very important point that some scientists have called mental time travel. What we mean by that is that human beings have the capacity to reflect about the future and also to reflect on the past. A very well-known neuroscientist who you've met, Your Holiness, at Stanford by the name of Robert Sapolsky wrote a very famous book called Why Zebras Don't Get Ulcers. And the idea that is captured there is that because human beings have the capacity to reflect on the past and anticipate the future, they spend a considerable amount of time worrying, ruminating about the past and worrying about events that may occur in the future rather than being in the present moment. In fact, a recent scientific study observed in a large sample of American adults, approximately 47% of their waking time, they were not actually attending to what they were doing. Their mind was wandering. They were either ruminating about the past or anticipating the future. They actually, 47% of the time, they were not focused on what they were doing.
So of course, if you're in that wandering mind state, so you can't achieve much. For example, you can't study well or do
Yes,
any research.
That may be a significant contributor to the problems in education in the United States, why we're number 27 in educational success and achievement. It's a big, we think it may be a very big problem.
So His Holiness is wondering whether that research has taken into account the difference of television viewing habit of, say, for example, people in the urban areas in the United States and the rural areas. Are you aware of that?
All of these individuals in the United States, in both rural and urban areas, there would be access to television. And so I don't think television exposure necessarily... we don't know the answer to that. I think that this is based on about 5,000 individuals, so it's representative, but there's a lot of variation among people. But I think even if you asked academics who are very focused in their work, have we had experiences reading a book, for example? We're reading a book and we turn a page and not actually know what was on the page that we just read. I think if we're really honest with ourselves, many of us have had that experience of the mind.
So it's only saying that if scientists acquire that kind of habits, then it's slightly worrying. It's a disaster.
You will never find theory
The reason I bring this issue up in a neuroscientific context is because the prefrontal cortex, this very large mass, which actually over the course of evolution has grown the most in human beings compared to any other species. So if you look at the relation between the size of the prefrontal cortex in relation to the remainder of the brain mass, that ratio is larger in humans than it is in any other species. And scientists believe that it's because of the evolution of the prefrontal cortex that allows us to anticipate the future as well as to reflect on the past. Those are skills which clearly are beneficial for many things that we do, but they also can get us into trouble. And that is why we are more likely to get ulcers than zebras, because we have the capacity to worry about the future and ruminate about the past in a way that other species do not. And it is because of the evolution of the prefrontal cortex. It has given us that ability, but it also gets us into difficulties because of that.
The object of your distraction can be anything, but the mind just loses its focus and gets distracted.
Well, we would make a distinction among certain kinds of distractors. So, for example, you can be distracted by a sound. If you heard your name being called, you can orient, you focus your attention. That's a certain kind of distraction. Then what the kind of distraction that we're talking about is more of an internal distraction. It's a distraction from our thoughts and our emotions, which pull us either to the future or to the past.
Not it. Because the senses, senses versus the thoughts. The senses are very present oriented. They cannot turn back or project into the future. So it's really a thought at the level of thought.
Yes, exactly. So one of the questions which is so important in this area of research is whether the contemplative traditions may have some useful exercises for us or useful strategies for, in some sense, harnessing the potential that human beings are born with to use them for more constructive purposes. So rather than getting distracted in this way and having our minds wander, to harness that capacity for specific beneficial purposes in a focused way. And so one of the areas of active investigation in what we call contemplative neuroscience is how contemplative practices may influence this area of the brain, the prefrontal cortex, in ways which enable this area of the brain to work in a way which is more beneficial rather than being afflictive. So I will end here, and I can just end with a question for Your Holiness about whether there are specific elements or strategies in the Buddhist tradition which you think would be particularly applicable in this context that scientists might investigate in this area.
So you have already done quite a bit of research on, adept meditators. So His Holiness is wondering.
So no matter what object, it's supposed to see training the mind focusing on one single point.
Way long.
Yes. Yes, and this has been a very fruitful area of scientific investigation, and now there are several very good studies published in the scientific literature that show that certain types of meditation can be beneficial in focusing the mind in this way and may reduce the propensity of human beings to show this mind wandering. It may help focus the mind in that way. There's still so many questions about how this area of the brain, the prefrontal cortex, is influenced. And also, what I wanted to end on is really the big questions, which still are as mysterious as they were at the very beginning of this enterprise, which is, how is it that our experience may actually emerge out of the neural matter that constitutes our brain, which of course is a conjecture, a hypothesis, or if you will, a bias that neuroscientists often begin with. That is a question that still is as mysterious as it was 2 or 3 centuries ago. We also have very little sense of whether it may be possible for consciousness to exist without this material substrate, and this is an issue, or at least without the material substrate that is the conventional material substrate that neuroscientists believe is the key to understanding consciousness. That's an issue that we know almost nothing about. And so one of the things I find most helpful in my own laboratory is just for us all to remind ourselves about these big questions that we know so little about, to help cultivate a little bit more humility as we navigate this difficult set of questions.
So, Your Holiness, if we were in your living room, let me turn this on. If we were in your living room in Dharamsala, gathered around the table in an intimate conversation, and you had just heard from these 2 colleagues about how very complicated their topics are, what would you ask them to go away and do? What charge would you give them as they...
The area where we need more inspiration is the distinction between conceptual and non-conceptual consciousness, and also sense consciousness. We have a position that on the level of conceptual thought, the appearance and the conceptualization kind of become blended, whereas that's not the case on the faculties, on the sense faculties. So in this regard, an area to investigate would be that of sleep state, because that's free from conceptual thoughts, yet that's an area where it is purely non-sensory, non-sensual, yet at the same time where thoughts have a play. And so it would be interesting to look at that area and then see whether one could come up with
a greater clear understanding of the distinction between the conceptual mental processes and processes that are not conceptual, not thought-related. So this is an
Now,
important...
senses of organs are the conceptual merit.
So, for example, like all the sensory experiences in the Buddhist epistemology seem to be beyond the level of thought. So it's not a conceptual processes; it's a sensory process.
Here, when
I look at the paper in front of me, it sees only whatever is presented there up front, and cannot see things go a little past or in coming in the future, whereas that's not the case.
One personal visual perception of this booklet on the table right now, what the visual perception really perceives is this very particular, present moment existence of that object on the table, that book. Whereas when you close your eyes and you think about this book, then you're at the level of thought, in the realm of thought, where then there is a conflation of time and space. So then you're no longer focused on a particular, phenomenon. So there is that distinction. So it's,
至少这里
no.
你对的没那么那个。
So it's also saying that one possible occasion for a good opportunity for research is in the dream state when someone is sleeping, because during that state most of all the sensory modalities are quietened. So whatever process that's happening would be at the level of this mental, not sensory. Visual, sensory, and auditory, they're all kind of switched off. And then furthermore, if you go down to the deepest sleep level, then again one would expect, different mental processes. Therefore, if one can see the brain signatures and the differences in the brain activity, that might actually show us a better way of teasing out what are the specific unique signatures.